Okay, so we're going to look at a little problem solving with things that involve the quadratic formula, and we'll also look at Pythagorean's theorem. So we'll start first with some simple problems before we get into Pythagorean's theorem. So let's assume we have a rectangular shape where I know the area of the shape. I want the area to come out to be 100, so 100 meters squared. And I know that I want whatever this side here is, I'll call this side X. I want this side over here to be six meters larger, or let's say 3 meters larger. So this has to be X plus 3. So whatever this measurement is, this measurement up here has to be 3 units longer. And when I get the area of this shape, this area has to come out to be 100. All right. Well, let's first take a look at how we can relate all these pieces here in one equation. Remember, when you find the area of a rectangle is length times width. So if I do my length times my width, that's going to be X times X plus 3, and that has to equal my area, 100. All right. Now that I have my equation, well, now we can go about solving it. Now, remember, this isn't the type of equation right now where I can say, this X equals 0, and then I just set this to 0. No. That only works if this is equal to 0. It's not equal to 0. It's equal to 100. So you can't do that. So what we're going to have to do is we're going to have to do the multiplication here. So I get X squared plus 3X equal to 100. Seeing that I have X squared, I know that I'm working with a quadratic. Since it's a quadratic, I'm going to have to set it to 0. So I'm going to have to subtract the 100 back over to the side. So I get X squared plus 3X minus 100 equal to 0. Now from here, you could try to see if this equation could be factored first. That means I would need 2 numbers that multiply to make 100. And then when I subtract them, I get 3. Off the top of my head, I don't think there's anything that multiplies to 100 that'll subtract to give you a 3. So we're going to have to use a different method to solve. This is where we use the quadratic formula. Remember the quadratic formula, the story I gave you. Negative boy who's bipolar, goes to a radical party, blah, 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 that one. So our quadratic formula again, negative b plus or minus b squared minus 4ac all over 2a. So I'm going to take my numbers here and I'm going to plug them into our formula so I can figure out what values of x are going to satisfy this equation. So remember, if there's no number in front of the x squared, you can assume it's a 1. So my a is 1, my b is 3, my c is negative 100. Let's go ahead and plug the points in. So that's going to give me negative 3 plus or minus 3 squared minus 4. My a again is 1, and my c is negative 100, all over 2 times a, which is 1. So let's go ahead and simplify the inside. Well, here on the outside, I'm just going to have negative 3 plus or minus 3 squared is going to be 9. 4 times 100 is just going to give me 400, and a negative times a negative is going to make plus. So I'm going to get plus 409, or positive 409. All over 2 times 1 is 2. From there, let's go ahead and get our answers. So if I do negative 3 plus the square root of 409, all divided by 2, I get 8.61. That's one answer. If I get the other answer, that's going to be negative 3 minus the square root of 409 divided by 2, and I get negative 11.6. 11.61. All right. Now, something to note. Since my answers right now are going to have to represent a side length, can I have a negative side length? No. Your side lengths have to be positive. Therefore, negative 11.6 is a miscellaneous answer right now. It doesn't fit the equation. It's an answer we can ignore. We need the positive answer right now because this is the one that could be a side length. Because I can't have negative side lengths, they have to be positive. So I'm going to ignore this answer here. This is the one I want. So x is going to be 8.61. X plus 3 then would be 11.61. Now, just to double check to make sure that these side lengths are going to work. If I multiply this number times this number, I should get something that's really close to 100. So let's check it. If I do 8.61 times 11.61, I get 99.9621. And that is really close to being 100. Remember, the reason why it's not exactly 100 is because this answer wasn't exactly 8.61. There were more decimals there. I cut it off. Had I used all the decimals that go with this, this answer would have come out exactly 100. All right, so let's take a look then at Pythagorean's theorem. Now, one thing to note with Pythagorean's theorem. Pythagorean's theorem only works with right triangles. So as long as it's a right triangle, Pythagorean's theorem will work. Pythagorean's theorem allows us to relate the three sides of the triangle together in an equation. And the equation is this. This side I'll call A, this side is B, the hypotenuse is C. The hypotenuse is always the longest side in your right triangle. It's the side that is across from the 90-degree angle. All right. The other two sides, my A and my B, these are the two sides that are going to make the right angle. Now, these three sides are related together in this simple formula. A squared plus B squared equals C squared. Whenever I have a right triangle where I'm trying to find a missing side, I can always do it by simply taking the numbers I have, plug them into this formula, and then solve for whichever variable that didn't have a number. Let me show you what I mean. Let's take, let's say I know that this side over here is 7, this side over here is 10, and I want to find this side here. As I said, the two sides that make the right angle are my A and my B. That means I'd put the 7 and the 10 here and here. So that's going to be 7 squared plus 10 squared has to equal, and the x is my hypotenuse because it's across from the 90-degree angle. So I'm going to take the x and put it here, x squared. From there, 7 squared is 49. 10 squared is 100. If I add these together, that's 149, and that has to equal x squared. I have to continue solving for x, so I got to get rid of the exponent. So I take the square root. So x is going to equal the square root of 149. Square root of 149, 12.21. So this would be the length of my hypotenuse right now, given these two side lengths. Now, it doesn't always have to be that you're trying to solve for the hypotenuse. Maybe I know the hypotenuse. So let's say I know the hypotenuse is 15. I know this side is x, and I know this side over here is 6. And I'm trying to figure out which side down here would fit to complete my right triangle. Well, we're going to use the same formula, a squared plus b squared equals c squared, in which now my hypotenuse is not the number I'm solving for this time. This time I'm solving for, it's either a or b, and it doesn't matter which one you call it because these two numbers are interchangeable. I could call this one a, or I could call this one a. It doesn't matter. What matters is which side you call c. That's the one that always has to be the same. And c will always be the side that is across from the right angle. So right now, 15 is my c value. And then I'll call this one a and I'll call this one b. So 6 squared plus x squared. So that's going to give me 36 plus x squared equal to, this will give me 225. And now since I have to get the x by itself, I'll have to subtract 36 over to the other side. So minus 36 minus 36. So x squared will equal, if I subtract off 36 right now, I believe I should get 189, 225 minus 36, 189. And then now I have to get the x by itself. So I will take the square root of both sides. So x will equal the square root of 189. 13.74. So that'll be this side right here. All right, the next video that follows this one here, the next video is going to show you when we have there are some problems that we're going to be working with in the project that we're going to be using Pythagorean's theorem, but the problems are going to get tad more complex. And so the next video specifically goes over those.